Hello student, welcome back. This is the fourth video on chapter Electrostatic. Okay student, today we are going to discuss about torque on electric dipole placed inside an uniform electric field and about electric flux. And remember also this derivation is very important for your exam. Now, because many times it asks, okay. So what is our heading? See, torque on an electric dipole placed inside a uniform electric field. What's torque, by the way? In class 11 we have to learn. Torque means something which causes rotation, okay? A force which causes rotation. Is it clear? Fine. So before you proceed with the derivation, try to understand the figure. Now see, in this figure, can you see this line? This line represents uniform electric field. Uniform means electric field will be same everywhere. Clear? Now can you see this two line? This AB. AB is the dipole. AB is the your dipole. You know dipole is what? Two opposite charge. This side will be minus. This side will be plus. Clear? Now distance between these two dipole, this dipole is 2a. This is the dipole length. Clear? And as you know that this is a plus charge, negative charge, right? And they are placed in uniform electric field. It causes some force. That force representing this side force formula is what? QE. Why plus? Because it's for positive, and here is minus QE. Clear? For negative charge. Clear? Now remember one thing student, if you've seen these two force, this force, they are same but they're equal but opposite in direction. Opposite in direction, right? Means they will cancel each other. The net force will be zero. Okay, the net force will be zero. It means that this dipole will not move away from here and there. Only this dipole will move, rotate like that. I'll get my point. The net force, this is then the opposite direction, right? The net force will be zero. Why zero? Because they are equal in opposite direction, right? These two force. And remember one thing, because of that, this dipole will not move like that or that this side. Only it will rotate like that. Why? They cannot move because force is zero. Net force is zero, right? Clear? So, so very easy this one. So force is how much here for this side, and for negative side. Clear? Now, you know what's the formula of torque? The formula of torque is either force perpendicular distance between the two force. Perpendicular distance between the two force. So one perpendicular distance should be there between the two force. So for that, just I'm making this one. Okay. So I'm mentioning this is your K. This is 90 degree. This is theta. Clear? And here will be what? Your dipole moment P. Dipole moment, remember? Dipole moment we have already done. Dipole moment, right? And dipole moment direction is from negative to positive. So your AK is perpendicular force or not? Either force, right? Now, okay, see, very easy. Torque symbol is tau, right? Either force. What is it? Either force. I'm taking this one force, and perpendicular distance. What's the perpendicular distance? Tell me. AK or not? Perpendicular distance A, this K. Now you have to find out the perpendicular distance value now. Now for that we'll do in right angle triangle. In right angle triangle A K B. Okay. So see, theta is this side. Clear? So easily we can use sine theta. What's the form of sine theta? Perpendicular by hypotenuse. What's the perpendicular here? AK is the perpendicular, right? Hypotenuse is which one? Your AB. So if you cross multiply, what will you get? AK is equal to AB sine theta. So AK. Now say student, look here, AB value is how much? AB is what? 2A or not? Dipole length. So in place of AB I can write 2A sine theta. Clear? Now see, what's the dipole moment value? Remember your dipole moment value. Now see student, um, okay, well, dipole moment we'll do later. See, directly we can do like that. Torque Q E, right? AK value how much you got? 2A sine theta. Now dipole moment value will use. See, P dipole P means what? Dipole moment, right? So what's this value? Dipole moment. Tell me. Just guess it. No need to guess. Also, we have already done in the previous video, right? Clear? This is this one, right? Clear? So, say Q 2A. In place of this, what I can write? Your dipole moment value P, right? E remaining sine theta, right? So if you represent this one in vector form, right? So this is the equation, or this one, right? So as you know that if you represent vector form, we're supposed to write the angles, right? Clear? Now this is simple, right? This is how we derive the formula, right? It is for only for 2 marks, okay? Now there are some cases where torque can be maximum. Okay, the torque can be maximum. See, for that, see, it's given here. If P is what? I already told you, electric dipole moment, right? If P is parallel to E, then theta will be 0. See, where's the P? Here, and this E on this side, right? Electric field, right? Electric field this side or not? Right? If the first the first one, they said that if P is parallel to E, parallel means, right, they are parallel here. No, right? If both are parallel, means theta will be 0. Theta will be what? 0 means same direction, right? So if theta is 0 means this is the equation, right? Clear? Sine 0, right? Sine 0 means what? 0. So minimum torque. So you have to know that for minimum torque, what's the value of theta? The theta value should be 0. Clear? For anti-parallel also same thing. Theta will be 180. So 180 also 0. Okay. Now to get, if theta is perpendicular, if electric dipole moment is perpendicular to electric field, then theta will be 90 degree. 90 means sine 90 is what? 1. So maximum torque. So in this case, so what we've learned is that to get a maximum torque, the theta value will be how much? See, to get a maximum torque, this theta value should be how much? The theta value should be 1. Okay, and to get a minimum torque, the theta value should be 0. Clear? So you have to know, because this in exam you have to write these special cases also. Special cases in this one. Clear? If they ask you. Clear? Okay, so this is done with the torque. So next we are going to discuss about electric flux. Okay, see, this is a very important topic. Electric flux. Now what's electric flux? See, the electric flux through a surface is a measure of the total number of electric field line passing through that surface. Or electric flux through a surface held in an electric field, the total number of electric field line crossing the surface in direction normal to the area vector. So remember one thing, area. What's area vector? Now listen here, student. Area, you know, area is a scalar or vector quantity. Always remember one thing, area is a vector quantity. Area is what? Vector. And remember always one thing, area is always perpendicular to the surface. So this is the surface, right? So area will be this direction, perpendicular to the surface. Area is always perpendicular to the surface. Example, if you're looking at your blackboard, example, so the board and your eyes is perpendicular not to you, right? Clear? So area is a vector quantity, okay, always. And it is a scalar quantity, means electric flux. So this is a simple electric flux, okay? Phi, we say phi, phi, or phi you say pronounce, right? Is a scalar. What's scalar? Electric flux is a scalar. So this is the formula, and its unit is this one, right? Clear? Now I'll tell you. I'll try to explain what's electric flux with the help of a diagram. Okay. Suppose this one surface, clear, an electric field line passing through the surface, right? So say this is the one surface, I took the electric field line passing through the surface or not, then we say this is electric flux. Electric flux means what? Simple, number of electric field line passing through a surface, Now suppose I'm to this side also example, how many line passing to the surface? Only 3, so I can write phi is electric flux symbol, right? Electric flux is 3, we will not count this 2 because these 2 they don't cross the surface, right? So only this 3 line, so electric flux will be 3. So always remember one thing, what is electric flux? Electric flux means number of electric field line passing through a surface. Is it clear? And it's what's the formula of electric flux? Tell me. Just now it's over, right? E, right, to surface. E electric field into electric field dot product of what? Your electric field is and this S, E is electric field, S is what? Surface area, or in some textbook is written A. You can write E also. Sorry, you can write S also, A also, no problem. Clear? Electric field surface area means electric field line passing, and this is surface area. Clear? Fine. Now, how to find this unit? Very easy. Unit, okay. Electric field, what's the value? Electric field, Newton per coulomb, right? And area is what? Will be meter square, right? So Newton. So this is the unit of your electric flux. Clear? Fine. And or we can say it's a Weber also. Clear? Now to understand this one, if you check your notebook, there is one relation is given, that relation between electric field and electric flux. Electric field and electric is very simple, very easy. See, for that you draw one figure, okay. Fine. This one surface through which electric field line will pass, okay. Now instead of, I will take one small surface. Under this again we will take one small surface. This is your n cap, okay, your unit vector. Clear? Now theta, this angle, this surface is your S, this small surface will be this one. Clear? Or you can write A, as I said before. Now as you can see in the figure, the electric field line passing through the surface also, the small surface also, right? So first we're going to consider the small surface, okay. If I consider small surface means I have to find out the small flux. Clear? Small flux, not the total flux, okay. So I'm considering this surface only first. So I'm finding out for small flux. So this is flux, right? What's the formula of flux? We can write E. You know, see, can you see the formula E and surface area, right? E, but see, as you can see, theta is here, right? So I can write cos theta, clear, into surface area, right? Clear? So just rearranging E cos theta, clear? Fine. Now, or we can write like also this one in vector form. As you know that in vector form, if you write, we don't write the theta, right? Clear? Now this is a small flux for this particular area. If I want to find out, actually this is the relation between your flux and electric field, okay. And if I want to find out the flux for total surface area, total flux, okay. Now total flux means, always remember one thing, when you find out the total, we do integration in physics, right? Integration, right? So clear? And remember one thing, if I like that, see, what is this? Your S means surface integration, okay, and this is called closed integration. Clear? For closed surface, if this surface is closed, example, okay, first let me tell you this one further. This is surface integration, so this value will put clear. Fine. And if the surface is closed, you agree my close, what I mean by closed surface, Also, in a closed surface means we say 3D surface, 3D, three-dimension surface. Okay, so if it's closed surface, we'll use close integration. This is called close integration. Okay, check your notebook. Okay, student. This is called close. The symbol for close integration. Okay, fine, clear. Or you can put this value here also, no problem. So this is the relation between electric flux and your electric field. Okay, fine. So you have to know the formula. Clear. So what's electric flux? Electric flux means number of field line. Okay, number of field line passing through a surface. Clear, fine. Now student, remember one thing, electric flux can be have two conditions. So like in the torque also we find out maximum torque, minimum torque, right? So same here, it have some conditions here. Now if the electric flux, see, listen carefully, if the electric flux is perpendicular to the surface, then the electric flux, right, crossing through the surface is given by this one. See, what I mean is that if the electric field, if the electric field, okay, suppose this one, this is a formula electric flux or not, E vector, right, and surface area, right? So if they say the electric field is perpendicular to surface, if the electric field and the surface perpendicular to each other, clear, then theta will be how much? Theta will be your 0 degree. Okay, so this is the formula, electric flux, right? So theta 0 means cos 0 is how much? 1. So we'll get this one, right? Theta is equal to ES, right? So this is called maximum flux. So just you have to know is that when we get maximum flux, when the electric field, and the your surface area perpendicular to each other, clear, that time we'll get maximum flux. When we get minimum flux, when the electric field is parallel to the surface, clear, when the electric field is parallel to the surface, then only we'll get minimum flux, clear. So I hope you have understand what's electric flux and about torque. Okay, so student, next video we'll discuss about Gauss theorem, very important topic. Next video, it's very important for your exam. Okay, please go through this video. If you have doubt, please ask. Okay, thank you.